So this question says that we have a dart that's thrown horizontally towards the x at 20 meters per second as shown. It hits y 0.1 seconds later, and we want to know what's the distance between x and y. So let's go through and actually label some stuff. So we know that this thing is given some initial velocity, which is actually in the x direction. It's thrown horizontally. So this is 20 meters per second. Well, it's kind of an interesting problem because really what they want to know is they want to know this distance. Now they want to know the distance between these two guys. So I'm going to say that this guy starts at a point of 0, 0. So my coordinate system is going to be right at the dart. And really what I want to know is I want to know how much negative y is going to be. So my coordinate's going to be a little bit weird, but we'll be able to interpret it. I expect my value d to be in the downward direction. So I'm going to just write out my equations. I know that I have, in the x direction, I have x equals x naught plus v naught t, 1/2 at squared. But in the y direction, let's see if we can just go straight to the end. Y is equal to y naught plus v naught yt plus 1/2 ayt squared. So my initial position, my initial velocity in the y direction times time, and my acceleration in the y direction term. All right, so we have a coordinate system. It tells us our pluses and minuses. We have some initial conditions. Let's see if we can plug things in and see what happens. So my final position is going to be at a value of d. I'm going to say minus d just because I want the value of d and I know it's in the minus direction. My initial position is 0. My initial velocity in the y direction, I have only horizontal motion. I don't have any vertical motion to begin with. So the second term is 0 as well. And last but not least, I'm going to have 1/2 minus g t squared. My minus g because g points in the downward direction, so I get a minus value pointing in. So I get minus d is equal to minus 1/2 gt squared. Well, this is really nice because it gave me time. I know the value of g. All I need to do is figure out what d is. So d is equal to 1/2 gt squared, which is equal to 1/2 times 10 meters per second squared. I'm going to just approximate g to be 10. And this is a value of 1/10 seconds. 0.1 seconds is 1/10 of a second squared. So this is going to be 1/2 times 10/100, which is equal to 0.5 times 0.1, which, if we work out the math on that, 0.5 times 0.1 gives me my answer choice of E. It's 0.05 meters. I misput. My units should be meters in here. Seconds squared cancels with seconds squared. My meters is left. My units work out at the end. So all we did is we just looked at the vertical equation, our original height, our original velocity in the y direction, and our acceleration in the y direction. We looked at our coordinate systems to put in the right minus signs, and we figured out where do we end at the end, and we found that d, this value of d, was a value of 0.05 meters.